Okay, I thought the best way to answer this question was to do it on video. So I'm going to send this video back to you, Madison. Take a look at it when you get it. If for some reason it doesn't work, then let me know, and we can try something else, okay? So you've got two problems here. They're really the same problems. So what I'm going to do is I'm going to just combine, I'm just going to do the problems together with the same numbers rather than two different sets of numbers because it's the same problem, okay? So I'm going to start off, I'm going to draw a picture first. So we've got this stump, and then we've got a creek, right? And there's a bicyclist, a kid on a bicyclist. And he's riding along like this, right? And he goes over the handlebars into the creek. Hands on the side of the creek. Okay? And so let's just talk about what's going on here. So he hits the stump, goes over the creek. His mass, the mass of the bicyclist, I'm going to take the first problem, is 70 kilograms. Okay? And he's thrown over the handlebars at a velocity of 12 meters per second. Okay? And he's going forward. And he's brought to rest in a certain amount of time. He's brought to rest on the side of the creek in a time of, in a delta t of 9 seconds, or 0.9 seconds. Okay? So the first question it asks is, well, what's the acceleration of the bicyclist when he's thrown through the air? Okay? Well, so the thing you have to kind of connect here is the fact that when he hits the stump and he flies over the stump and flies into the air, he has a certain velocity. Well, this velocity, this 12 meters per second velocity, is his initial velocity, VI. Well, what's his final velocity? Well, his final velocity is he's brought to rest. Okay, so his final velocity is 0. Okay, so that's kind of the trick to the question. So if you think about it, the acceleration, by definition, is the change of velocity over the change in time. Well, that's his change of velocity. He starts at 12 and he drops to 0 over a time of 0.9 seconds. So I can rewrite that. V final minus V initial over delta t. Okay, so V final is 0. His initial is 12, so that's minus 12. Okay, and then it's over 0.9 seconds. Okay, so if you think about that, then you notice if you do this math, this becomes minus 12 over 0.9. So his acceleration then is going to be 12 divided by 9, but it's going to be negative. So it's going to be minus 1.33 meters per second squared. Now it's negative, and that's because the acceleration acts backwards. It slows him down. He's traveling forward, but he's slowing. Okay, so the acceleration is negative. So the answer to this would be minus 1.33. Okay, now then it says, what's the magnitude of the force exerted on the bicyclist by the creek? Well, the force that's exerted on him, okay, the force is equal to the mass times the acceleration. Well, his mass in the first problem is 70 kilograms, and his acceleration is minus 1.33. So the force that's exerted on him is just 70 times that. Okay, it'd be minus 93.3 newtons. Now, it says here, so that again, the force is backwards because the force that's exerted on him acts backwards to stop him. Okay, but this asks for the magnitude of the force. Okay, so the acceleration up here is a negative 1.33 meters per second squared. And if I use the numbers from this first problem, the force, the magnitude of the force is going to be I drop out this negative sign because the magnitude is always a positive number. I don't care about the sign because the sign is the direction. So the magnitude of the force is going to be 93.3. That's based on the problem, the first problem, okay? Newtons. Okay, so that's the answer to those two questions. So there's two parts. One is you work out the acceleration, okay? And if it wants the acceleration like this, it's going to be a negative number because it's backwards. It's in reverse, okay? Now, if it asks for the magnitude of the average force, which this one does, then you're going to give it a positive force, but in reality, of course, it's a backward force and it's negative, okay? So that's the question, okay? That's the answer to this question. So hopefully this helps you out, all right?